Okay, so I think I'm live, right? And I'm properly audible also. Waiting. Why are you waiting for so long? Okay, so yeah, I'll just do one check quickly that whether I am properly audible or not. Just someone just confirm me whether I'm audible or not. Okay. And till then, what I'll do is I'll just share on Discord so that other people can join. I think I'm audible, right? Yeah. From my end, it's showing that I'm audible properly. Great. Okay, so let's start with today's all the problems. Okay, so if let me just put this, let me just pin this and keep it aside. And I'm audible, right? I'm audible, right? I'm audible, right? Okay, yeah. Let's start with the first question. Okay, sorry. Yeah. See, deletion and difference. Okay, you're given an array A of n integers of length n. You can perform the following operation on it. You can choose any two indices I and j, and such that a of I and a of j both are equal. Okay. Now the thing is that we have to delete both a of I and a of j from A and append the modulo of a of I minus a of j to A. Okay. The length of the array reduces by 1, which is right. Yeah. And all remaining elements are reindexed from start to that. This is not important only. Okay. Because we don't need to focus on it that much for now, for the time being. What we have to do is we have to find the minimum possible length of A after performing this operation several, possibly 0 times. Okay, so see, the indexing for now, it is not our main concern, right? Because we are going to mostly focus on the fact that we have to reduce it as much as possible. That is what our question is demanding for us. Okay, so let's go on to Excalibur and explain you. So let's say if I'm having the whole array like this. Okay, and after that I have the array. After that I have all the arrays like this. What I can do is I can find out like two elements that are equal, right? That is a of I and a of j. So let's say this element and this element. Okay, these two elements are equal. Now since these two elements are equal, so I can do what? I can delete both of them and replace it with a mod with the absolute difference. Now since if both the elements are equal, okay. Now since both the elements are equal, so we know one thing, that the absolute difference will be x minus x. So let's say both the elements are of value x, so the absolute difference has to be x minus x, right? Which is nothing but 0, right? Now see, once we are done with this absolute difference, we don't even need to have this thing. Okay, a of I minus a of j absolute value. This is very much like, this is like an extra information for us, which is just there to confuse you completely. Okay, Simply you know one thing, that you are going to delete a of I and a of j, which is equal, and replace them with a 0, with 1 0. That is what we have understood from the whole problem, right? And we have to minimize it as much as possible. So let's say, just like this x, there are few elements. Okay, so let's say if there are 5x's, okay, 5x. Okay, I think I forgot to follow myself, or what? Yeah. So basically there are 5x. Okay. So in this case, what we can do is, we can take out a pair of x and make them 0. So we are remaining with 3x, right? I don't know why there is so much lag from this Excalibur draw. Let me do one thing. I'll just write it down like this only. Okay. So after this, what we can do is, we can have 2. Okay. I mean, sorry, not 2. We can have 1, because we have reduced it more. Okay. After this, what we can do is, we can't have it more. We can't reduce it more, because at a go we can reduce 2 of them. I'll just put off this Excalibur, man. This is too irritating. Okay. Now see, since you have come to this 1, which means that this 1, it will be just alone, without anything else. Now since if this 1 is alone, which means that one occurrence of x will be there in the whole array, right? Even after reducing the whole thing. So one thing that we can say from here is that, no matter how much we are going to minimize it, one x will be there. Okay, because our aim is to make the possible length of a minimum, right? But one a will be there. We are sorry to say, but one a will be there. Now since one of the x is there, so how can we find out whether there will be one x or not? Because we know one thing, that if this was, instead of 3, if this was 2, okay, so in that case there would be 0, right? No x's. Now the thing is key, like, if it is a odd number, then there will be 1, and if it is an even number, then there will be 0x. Okay, so from that we can find out, like, we can traverse throughout all the elements of the array and find out, whenever you find a number which is odd, that means that one of its occurrence will be there in the whole remaining array, and it will be contributing to some zeros. Okay, we don't know how many zeros will be there, and we are not even concerned about that. Till some extent we are not even concerned about that. Okay, but we have to be concerned about that. Why so? Because let's say, if there were 5 x's, okay, and after that I got 1 0, and then from 3 I got 1 0. Okay, so I get various number of zeros, right? So now you're going to tell me that it means that the number of zeros that are there, right, the number of zeros should also be a kind of concern for us, right? But let me tell you one thing, that the number of zeros is not a concern for us, and I'll tell you this after I explain throughout all the situations, okay, all the test cases. So first thing, the first thing that we have to do, it is that, find out, traverse over the whole array and find out whichever is a odd number. So we can say that it is going to be giving us, if for any number, if the frequency of that number is odd, so that means there will be at least one element of that number in the final array. Okay, good, we are good with it. Now see, we are done with this, but one thing that I was just explaining you, that even after reducing them, we are getting some zeros, right? We are getting some zeros. Sorry, we are getting some zeros. So how can we reduce the zeros further? What we can do is, we can take 2 zeros and make it 1. Okay, and remove 1 0 from it. So basically, in this case of 0, we don't have to find out what is the frequency of 0. Okay, for all the remaining elements, we find out what is the frequency of them, and if it is a odd, add 1 to the answer. If it is not, we don't add it to it. But for 0, we don't have to find out. For 0, we just have to find out if there is a 0 or not. Okay. So what we can do is, because we know like even if there are 5 zeros, okay, let's say if there were 5 zeros, 1, 2, 3, 4, 5, okay, so we can group these two zeros, delete them and make 1 0. Then group these two zeros, delete them and make 1 0. Then group these two zeros, delete them, make 1 0. Group these two zeros, delete them and make 1 0. So no matter how many number of zeros are there, at the end you're going to have 1 0 if there is at least 1 0, or you have reduced any number to 0 or not. So now let's move on to the solution that I have coded up for you guys. If you guys find anything out of the box, just don't hesitate to ping me. I mean, don't hesitate to write it in the live chat, okay? So, see, I'm taking the ARR, I'm taking the frequency array, and in this frequency array, what I'm doing is basically I'm taking the input, I'm taking the frequency of all the elements, and then from 1 till n, I'm going to check if the frequency of that specific element is greater than 1. Okay, which means that if there is at least 2 elements of that number, so we are going to reduce it to 0, right? Which means that there is a 0. So for that case, we can say that there is a 0. Otherwise, there is no 0. Okay. And if it is so, what we are going to do, we are going to make frequency I mod 2. That is, if it is odd, it will be 1. If it is even, it will be 0. Because at the end, what we do, we are going to add the answer, add the frequencies to the answer. Okay. So that is the reason we are going to do it. I just explain you why. This X thing. Okay. From 5, we got 1. But if it was 2, we got 0. So that is the reason. Okay. So after you're done with this, now you have to check out what was the frequency of zeros plus if we got any 0 or not. Okay, so let's say if we didn't get any 0 only and the frequency of 0 was also 0, I mean there was no zeros at the beginning and we haven't even reduced anything to 0. So that means that there is no 0 only. So 0 is not going to contribute to it. Okay, but if there is at least even 1 0, then there will be 1 0 in the answer. And I have explained it just now. Okay, is it clear? Actually, I won't be like getting that much into this problem because I think it is clear for you guys. There were a lot of submissions, right? Yeah, a lot of submissions for this. I think I didn't refresh the whole thing now. So yeah, obviously more than this, more than 1789 submissions will be there. Okay, so let's move on to the second problem. Okay, mystic slimes. Now see, okay, there are n mystic slimes arranged in a line, and the power of the ith slime is a of I. You need to perform the following operation until one slime is remaining. You can choose two adjacent indices and let the ith slime eat the jth slime. After this operation, the power of the ith slime becomes maximum of 0, a of I minus a of j, while the jth slime is removed. Here it is not necessary that a of I has to be greater than equal to a of j. Okay. Now since it is not necessary, which means that if it is not so, then we are going to make the value 0, and if it is so, then we can keep the value as like this. Okay, that is what they are basically meaning us. So let's understand what the problem is all about. Just excuse me because like I am not using my pad, my touch pad, so I may not be that good with, I may not be that fast in the writing thing. So yeah, just excuse me, okay? So let's say if I am having a array, okay? I'm having the array. What I can do is I can choose any two consecutive elements and find its difference. Okay. Now it is up to me which one I want to keep. I can keep this and eliminate this, or keep this and eliminate this. Okay, so if I'm keeping this, so what will the value of this become? It will become this value minus this value. Okay, and if the value is lesser than 0, which is the case if this number is lesser than this number, okay, if it is so, then we can directly write, instead of getting it as negative number, we can make it 0. Okay, what we have to do is, we have to, like, after we are done with it, after we have reduced the whole thing, whole array into one number, because yeah, obviously we can reduce the whole array into one number, we have to maximize this number that is that has been reduced to, that the array has been reduced to. Okay, now since we have to maximize the number, so what is the approach that we should come up with, right? Any idea? Anyone? Anyways, like, people who can't write it down in the live chat, it is because I have enabled members, no, not members only, subscribers only chat. Okay, so yeah, you can subscribe my channel. And anyways, I'll just mention Sanjay. Why can't I mention Sanjay? I can mention myself. I don't know. Why can't I mention him? Okay, so this is what the whole question is basically telling us. Now, what is the best approach to do it? Okay, what is the best approach to do it? Now see, since we don't know, since we know one thing, for sure, that the whole thing, the whole array, if it is reduced to a specific number, so it will be obviously a good approach to say that the number is already present in the whole array. Okay, now it is never possible that we are going to have a number which is way greater than a number that is present in it. I mean, it is greater than the maximum number. Okay, because we are just subtracting numbers from each other, and in one operation we are not making any number negative. So a positive number minus another positive number, if it is even 0, it can't be greater than that specific number from any of the specific numbers. Okay, what do I mean by that? So let's say if I'm making x minus y, and I know that y, this y thing, it is greater than equal to 0, because even after reduction also, it is a positive number. So which means that this will be obviously lesser than equal to x, right? Even after a few number of reductions, it will be always be lesser than equal to x. Okay, so that is what we can come up with for now. Now, apart from this fact, what we are going to have more into consideration is that how can we make this y as 0, because we have to maximize the whole thing, right? So we have to make this y as 0. So now if we want to make this y as 0, so which means that we have to make the whole operation over here as 0, and this whole operation over here as 0, right? Now remember one thing, that if you're choosing any two adjacent indices, you can make it 0. How can you do it? If this is smaller and this is greater, okay, you do one thing. Let's say this is smaller and this is x, okay, and this is greater and it is, so just perform x minus y, okay, because if you perform x minus y, it will be lesser than 0, okay, and since it is lesser than 0, you can make it 0, and our aim is to make this 0, right? Which means that towards the left of that number, if there are at least two blocks towards the left of it. So left can be 0, and towards the right of it, if at least there are 2 blocks, then it can be 0. Okay, and if both are zeros, we are going to go with that this is the number that is going to be the maximum. Okay, now see, since I know that this is the number that has to be maximum and both are zeros, so I can compute it. But what if both are not zeros? Okay, what if any one of it is not zero, or what if both of them are not zeros? That is, both of them are not zeros. That is a special case if the size is of 3. Okay, size of 3, which means towards the right also it is not 0, and towards the left also it is not 0. Okay, if it is so, then what we have to do is, from this number we have to subtract this number and as well as this number, and if it is a negative number, then the output will be 0, otherwise the output will be whatever it came. Okay, that is our solution. Because why is it so? What we can do is we can reduce. I'll just use a different color. We can reduce these two elements into one and keeping this separately, and after that what we can do is we can reduce the whole thing into one. Okay, in the green what happens from this? Okay, in the green what happens from this? I'm going to subtract this, and the blue what happens? We are going to check how many elements are towards its left, how many elements towards its right. If there are more than 2, so there is a possibility that that element is present. I mean, that element is the answer. So from that we can just calculate them and we can have the maximum. So if you want the code for it, I'll quickly walk you through the code for it. What I'm doing is I'm just taking the inputs. I'm getting the max. This is not needed actually. Okay, this part is not needed. I was just experimenting with it. The answer is initially -1, making it as minimum as possible. And then what I'm doing is I'm going to check if it is the first element. Okay, first case, if it is the first element, which means towards its left there is no element only. So this 2 thing doesn't work only, right? I was searching for 2 elements, and if there is no element, I mean that means that I have to take the elements that are towards its left, right? I have to make it minus. But if there is no element only, then also we can say that there is a 0 towards its left. Okay, so we don't have to take that thing into care. We don't have to take that thing into consideration. So if it is 0 and towards its right there is only one element, that is the last element, that means it is going to be the present element minus the next element. If the element is the last element and towards its left is the first element, that is the only element towards its left, that means I have to go for AR of I minus AR of I plus I minus 1. Now this is the exceptional case that I just went through. That is if n is equal to 3 and I is at the middle, which means we have to subtract both the previous as well as the next. Okay, and if I is equal to 1, okay, then in that case, yeah, I have to subtract the previous element, and if it is the second last element, so I have to subtract the last element. Okay, otherwise any case other than this, I know that I can make both the left and right 0, so the answer can be like I can take AR of I into consideration only. So for all this element I am doing the checks, and after done with all the checks, I'm going to just print the answer, which is the maximum that I'm getting. Okay, okay. Should we move on to the next problem? Since the audience engagement is not that good, so I'll just use a poll. And it is not like that no one is watching it, like there are people who are watching it. No response. Okay, let's move on to the next problem. GCD Add Size. Okay, what does this problem state? It states that you're given a sequence A of size n. Your task is to choose a non-empty subsequence B of size A, of A, to maximize the function fb. What is f of b? F of b is the length of b plus GCD of all the elements in b. Okay, so what we have to do is we have to find out a subsequence of A, that is b, and we have to maximize the score of that, and the score of that can be said to be the length of the b plus the GCD of all the elements of b. Okay, I'll just make sure that whether I'm lagging or not. Okay, I'm lagging a lot. I have to fix this, and it is fixed. Okay, great, it is fixed. So let's understand this problem first. Okay, I think I know what to do. Stop the session. So let's say I'm having the A. Oops. I'm having A. Okay. From these, we can find out a subsequence. Okay. So let's say the subsequence looks like this. Okay. This element, then I take this element, then I take this element, then I take this element. So this is a subsequence. So what is its score? Its score is going to be 4 plus 4 plus GCD of all the elements. I'll just use different colors. Okay. So let's say this is red, this is green, this is black, and the last one is blue. Okay. So what is the GCD? GCD of red, green, black, and blue. Okay. So we have to find the GCD of all of them, and we have to, like, what we have to do is we have to basically maximize the whole thing. Now the I'll just go with, I won't be going with the basic approach, what to do, what not to do. I'll just go with the solution that I initially came up with. The initial solution that I came up with was, for every specific element, find all its divisors, and also for those divisors, what you can do is, you know what, that you can find a divisor of a number in big O square root of n. Okay, so let's say over here it is a of I. So big O square root of a of I. Okay, you can find it for every specific number, you can find it, and since you're also traversing through it, so it is going to be big O n into square root of a of I. So after you're done with it, what you can do is you can find out all the devices and just add them to the frequency of it. Okay, which means that if you're adding, so let's say the number 3 divides all of them, which means that if I want the GCD to be 3, I can take this subsequence. But let's say if I'm taking, or let's say the number 6 divides all 4 of them, so if I'm taking the GCD to be 6, this is a valid thing. Okay, but let's say if I'm going to take 3, then there is also another element, okay, which 3 divides. So in that case, obviously I can take it as 5 plus 3. Okay, but if I'm going to take for 4, it has to be 4 plus 6. So obviously 4 plus 6 is greater than 5 plus 3. But I'm just taking an example. Okay, what we can do. Now see, since we can take this 5 plus 3, what we can do is, for every specific element, we are going to find its divisor, and in the frequency array, we are going to make it plus plus. Okay, let's say I'm having a frequency array and I'm going to make plus plus to it. I will explain with one of the examples. Okay, you don't need to worry. But what happened in this is, I'm going for big O n into square root of a. Okay, you were able to solve this. No, I couldn't solve this, but I came up with an approach which I'll just share with you guys. I was about to solve the fourth problem though, but what we came across was a of I is of 10 to the power 12. Okay, and square root of 10 to the power 12 is 10 to the power 6, and 10 to the power 6 into 10 to the power 5 is 10 to the power 11, which is going to give you a TLE. Okay, state of TLE. Now, if you want the solution, what I have done for that TLE, I can show you so that you understand that what I'm talking about. Okay, I'm traversing through all the elements and I am checking all its factors, and I'm putting map of that plus plus and map of air of I that plus plus. That is for all the factors I'm making it plus plus in the frequency map. Okay, clear? After that, for every element in the map, for every key value pair in the map, what I'm going to do is I'm going to make the number plus frequency, that is key plus value, and whichever is the maximum I can print it out, but I will be getting a TLE over here, right? See, I am not sure whether I can share it or not, but I think the Codechef uploads their official solution, so I will try to check out that and I will try to explain you guys that. Okay, now see, explanation. Yeah, I know the explanation. Okay. So they have done it in Bigo and Login. What have they done? Let's see. Because the approach is going to be the same only. Okay. Explanation. The expression we wish to maximize is the length plus GCD of the subsequence. Suppose we fix G to be the GCD of the subsequence. Great. Then every element of the chosen subsequence must be a multiple of G. Great. Clearly, it's best to just take every element that's a multiple of G into the subsequence in an attempt to maximize its length. Great. If the GCD does equal G, great. Otherwise, the GCD will be a multiple of G, giving us an even larger value. Great. Of course, the subsequence must be non-empty for this to be valid. We now already have a very slow algorithm to compute this answer. Fix a value G, that's a factor of at least, yeah, that is a very slow. However, checking all G is definitely impossible, so we need to do better. What is he doing? Let mx is equal to maximum of A. That is, let's say 10 to the 12. Okay. Observe that G is equal to mx. Already gives an answer of mx plus 1. Perfect. What do we mean by that? So let's say if you're having an array and the largest element is there, so what is the largest value that we can have? We can take this into consideration, right? So that is this element plus 1. What is 1? 1 is the length of that array. Okay, one length of the sub array or subsequence. Yeah. Okay, great, great. Which means that G has to be lesser than mx plus 1 minus n and can never be optimal. At best, we have to subsequence of length n, but even the sum isn't exceeding mx plus 1. This means we really only have n possible candidates for G. Great. What do we mean by that? That is, let us say that for example, if all the elements are maximum, if all the elements are same in the whole array, so what is the best thing? That is one element plus n. Okay, because if all the elements are same, that means the GCD is also that element only. So let's say if the maximum element is mx, so what is the best answer that we can come up with is mx plus n. Okay, but if it is not so, that means if at least one element is not so, which is mx plus n minus 1. Okay, mx plus 1 minus n. Sorry, this is not that thing. I'll just explain you. Okay, mx plus n minus 1. So in that case, we have to go for other checkings. Let me end the poll over here. Okay, now let's see what he's doing, this guy. So yeah, obviously we need only n possible candidates, because if we are going to take, let's say if there was only one element that was as great as this, mx. So this n wouldn't be there. So it will be mx plus 1 that I was explaining just now. Okay. Now if it is mx plus 1 and all the remaining elements are some number, let's say mmx. Okay, mmx. All the elements, other elements are mmx. So what is that value going to be? mmx. So to that I'm going to add n minus 1, because total length is n, and if I'm removing one of the maximum from here, it is going to be n minus 1. Okay, but that is not the case also. But like, let's say if that is not also the case, so we can come up with a very good approach that no matter what, since we have, this is the maximum. Okay, this is the maximum that we can reach. So if at any position we are finding any number, okay, any number, it has to be lesser than this. It has to be greater than this for that to be valid. Otherwise, we don't need to check that divisors only, right? Because we are going to check for whichever is going to give us the most optimal maximum answer, right? So that is what he's telling us. Now, since we know this, so which means that there are only n possibilities out there. Because if we are going for mx, or let's say if there is a number, so this mmx, I don't know what is the value of mmx, okay. But what can be the value of mmx such that this condition holds is our main question. That is, this is greater than this. Okay. What is the condition? So the condition is very simple. mmx has to be greater than mmx. It has to be greater than mx plus 1 minus n plus 1. Right? That is mx plus 1 minus n. Because we don't even need to consider this minus 1. Let's say, like, for our better opportunity, even this minus 1 also we are going to ignore. Okay. So we are also going to ignore this. We could go for this plus 1, but let's say we are also ignoring this. That is, just for our safety, we are making it more. Okay. So what is this value? mx plus 1 minus n. Over here, what is he writing? ms plus 1 minus n. So g should be lesser than that. Clear? Sorry. Yeah. G should be lesser than that. Clear? Which means we only have n possible candidates for g. Great. That has to be in this range. mx minus n plus 1 and mx. So for each g among these, we would like to know how many elements of A are divisible by it. Okay. So from this range, if we can find out how many elements of A are divisible by it, we can find out what is going to be the answer. Right? Because the GCD has to be in this range. Okay, the GCD has to be in this range. So for each G among these, we would like to know how many elements of A are divisible by it. To compute this quickly, rather than iterate through every element of the array, we use an idea similar to sieve of Eratosthenes. Now, sieve of Eratosthenes, what is sieve of Eratosthenes? If you guys don't know about it, let's say, let's say this is a number line, okay? And I want to find out all the elements, all the numbers that are divisible by 3. Okay. So what I can do is, for all the third elements, I can cancel it out. Okay. So that is what we are going to basically do over here. Let frequency of x denote the number of occurrences of x in A. Okay, so initially we can know one thing, that like if a number is present in A, so that means that it is divisible by that number, right? X is obviously divisible by that number. So frequency of X is initially there. Now the number of multiples of G in A is frequency of G plus frequency of 2G plus frequency of 3G. That is the Sivo Eratosthenes thing that I just explained. Okay, the time complexity of this thing can be calculated similar fashion to the Sivo Eratosthenes, with G is equal to mx minus n plus I. Okay, which means that at most n by I multiples of G should be calculated. So the number of times we need to look up is the summation of n by I. Okay, so what is it? It is n plus n by 2 plus n by 3 plus, and we go on doing it. Okay, now if you don't know how to solve it, so there is one thing, that is I don't know whether you have gone across this formula or not. That is 1 plus 1 by 2 plus 1 by 3 plus dot 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 plus 1 by n is equal to nothing but log of n. Okay, clear? So we can do it by that method. So is it clear? If you want to go through the code, I'll walk you through the code of the editor. Very simple code. What he is doing is making the frequency map, that is 0 into n plus 1. That is there n plus 1 elements of 0. And what he is doing, like he is finding the range, and if mx minus x is lesser than equal to n, then frequency of mx minus x plus equal to 1, that is just incrementing it into it, then answer is equal to mx plus frequency of 0 for I in range, x is equal to mx minus I. If x is lesser than equal to 0, break. Yeah, obviously you have to break it up, and ct is equal to 0. So this is basically the code. Okay, if you want the, if you obviously you will get the code if you want it, but I think most important is the solution of how I have done it. Okay, okay, let's move on to the fourth problem. Obviously this will be ours. Yeah. Okay, maximal sum. You're given an integer array A containing n elements. The pair L, R is called good if max of all the elements till A is equal to max of all the elements from L plus 1 to R is equal to max of all the elements from R plus 1 to N. Okay. What you have to find is, you have to find the minimum value of sum of A 1 to L plus L plus 1 to R, minus L plus 1 to R plus sum of R plus 1 to N. Okay. And the minimum one also. Okay. What do we mean by that? You're going to have an array state of in that array. You have to divide that array into 3 parts. Okay. Let's name these parts. So this is A, this is B, and this is C. Okay. And the max of all the 3 parts is going to be same. So first of all, you have to find the maximum value of A minus B plus C. Okay, and the minimum value of it also. Now see, A minus B plus C can also be written as this A plus B plus C minus 2B, right? It can also be written as like this. Now if you're writing it like this, we know that this is going to be constant, this A plus B plus C. So we can erase it up and write it as sum. Okay, sum. Now since sum is constant, so if I want the maximum value, I have to make this B minimum. If I want the minimum value, I have to make this B maximum. Okay, clear? How we are going to do it? Works fine, great. Now what we can do is, since we know that the max of all these three parts are going to be the same, okay, so we have to find out for every specific element from 0 till n, or let's say n plus 1, what is their frequency. If for every specific number, so let's say for 0 the frequency is 3 plus 1, that is 4. Okay, like if it is greater than equal to 3, okay, if it is greater than equal to 3, undoubtedly you know that it will be divided into 3 parts. But let's say if the number of zeros is 2, okay, which means that one of the 0 will be coming to, let's say, A, and the other will be coming to C. Or instead of making it to C, you can make it to B also, which means that for C the max is 0. What is max? Max is the minimum non-negative number that is present, that is not present. Okay, so for C max is 0, but for B and A max is not 0, so it is not possible, right? It is a minus 1. So from 0 till n plus 1, we have to go on checking till this frequency is greater than equal to 3. Okay, clear? Now since we are going on checking it, that it is greater than equal to 3, greater than equal to 3, the moment we find that it is not greater than equal to 3, but it is 0, okay, so in that case we can say that this is going to be the position where it becomes 0, that is going to be the max for all the 3 partitions. Okay, but if it is not 0, let's say if it is 1 or 2, okay, 1 or 2, then we can say that it is going to be minus 1 minus 1, that it is not possible only to make it into 3 partitions, I mean uh, 3 parts. Okay, you can't make it into 3 parts. I just explained you why. Because if it is 2, then this 0 and 0 will be over here, so C will have a max which A and B can't have. If it is 1, then B and C will have a max which A can't have. Okay, but if it is 0, then A, B and C can have the same max, and if it is 3, then also A, B and C can have the same max. Okay, so for 1 and 2 there is an exceptional case. So if 1 and 2, if you find a 1 and 2, you can directly say that it's a minus 1 minus 1 return. Minus 1 means this condition. Okay, that if no good pair presents, print minus 1 minus 1. The first moment you encounter a 0, it means that this is going to be the max. Now since we have to first of all minimize, let's say first of all we are going to maximize the value of B so that we get the minimum value. Okay, so what we can do is we have to traverse throughout the first part till we find that the max is equal to our expected max, that is this, where it was 0. Okay, and then we can also traverse from the end till we find the max. So once we know that the max of A and max of C are same, okay, we have got it, we have got the number. So we can say one thing clearly, that this is the maximal length of B. Okay, you can't have it more than this. You can't have it more than this. So this is the maximal length. So you can find the sum of this and make sum minus 2b. Okay, clear? But how can you find the minimum of it? Okay, so how to find the minimum of it? Very simple. From this b, you know it's max. Okay, you know the max. So now what you can do is you can find out and print, and have all the frequency of the elements into a frequency array or frequency map. And then you one by one, using two pointer, what you have to do is you have to remove elements, go on removing elements from the left. Or let's say you don't even need two pointer. Go on removing elements from the left. Okay? Till you find that the frequency is becoming, like there's any number between 1 and m, 1 and max, where the frequency became 0. If it became 0, so we can't remove it, right? So that is one of the approach that you can do. Great. Well, but what if there is a tie? That is, if you remove one element from here and if you remove one element from here, like both of them are same. So which element should you remove? So over there you will come across an approach that you may think that it is going to be recursion, right? Well, that is the part that I don't know how many people are getting what I'm talking about. Okay, or is it just me only that I'm getting it? But, so yeah, that is it only. Okay, so that is it. So what you are doing is the main solution that we have to come across is for B. How much less can we shrink this B? Okay, how much less can we shrink this B on more? So that shrinking is not in our control. So I think for that I have to go through the editorial. And this is going to be the last explanation, okay? The last question that I'm going to explain. Okay. Well, I don't know about what he has done, but what I can come up with is like for every specific element, what you can do is you can find out, you can go on traversing and find out what is the minimum position that you can traverse so that you can get the max. Okay, so you know that this is the minimum length. That is what I was thinking of, but yeah, that is going to be a little bit complex, but I don't know how to make it shorter. Okay, because it will take you, no matter whatever you're doing, it will take you big O n into max. Okay, it is going to take you big O n into max. But over there, I saw that whoever has done the solution, he has came up with a big O n approach. But I like for now I can't understand what he has written. Okay, so yeah. So let's quickly rate the problems before I end the video. For today, the ratings will be only based on three categories: easy, medium, and hard. As simple as that, okay? The first problem was deletion and difference, mystic slime, GCD add. Okay, first problem was between easy and medium. Second problem was medium. Third problem was between easy, hard and medium, and the last problem was hard. But I think they rated it as easy only. Yeah, they rate every problem as easy. I don't know why. So yeah, that's it. The rating. That's it. Let me end the video. Okay. So yeah, that's it from my side. Consider turning down. Yeah, I'll do it. Yeah, that's it from my side. Thank you. Radhe Radhe.